So today my presentation will be separated in two parts. First, I'll be talking about a research project that I did during my PhD at the University of Illinois that ended up in this published paper with Dr. Connor Sibyl and also Dr. Fred Billow. We'll be talking about linking soil tests to soybean productivity. And at the end of the presentation, I'll talk about the importance of soil organic matter for soybean yield, specifically here in Illinois. I see that soybean responds a lot to the nitrogen that is in the soil organic matter, and we'll be talking a little bit about that. So to start my presentation, I want to put a little bit of a context here on how is soybean produced in Illinois. So data tells us that only 35% of soybean acres in Illinois received P application. This was in 2020, but we don't expect that to change much now. And the same is true for potassium. Not a whole lot of the acres are fertilized for potassium. A lot of the soybean in Illinois is being a residual feeder, meaning we're applying fertilizer to the corn and expecting the soybean to utilize a little bit of what's left over or utilize what is left in the soil. Does that mean that soybeans don't require a lot of fertility? They don't need fertilizer applications? Well, I think we can grow good soybeans in Illinois even without applying fertilizer to them because of one specific reason, that is the soils we have in Illinois. 88% of Illinois consists of moldy soils or alphy soils. These are the two most fertile and productive soils in the world. From 2014 all the way to 2021, and looked at 1,340 soil samples collected in 6 different locations in the state of Illinois, covering northern Illinois, central Illinois, and southern Illinois. All these soil samples were collecting the same way, from 0 to 6, 10 subsamples from the trial area at pre-plant. And all the soil samples were analyzed by the same laboratory. I'm not saying one laboratory is better than the other, but consistency here is very important. So we were using the same laboratory for all these soil samples. Soil analysis, this is the methodology we used. Also, in my opinion, it wouldn't matter here. It's just that we were being very consistent using Mehlich 3, ICP, pH water, organic matter and loss of ignition on ignition at 360. What we did was we correlated yields from the unfertilized control plots, meaning those plots were relying only on what we had in the soil. And then we could correlate those yields from those unfertilized control plots with the soil test that we had at pre-plant and see, is there a correlation between phosphorus and higher yield? Is there a correlation between potassium and higher yield? With those soybeans relying only on what the soil was supplying, no fertilizer added. The statistical analysis, we did a simple Pearson correlation. And here I want to show you guys the results. A lot of results. And at the end, we did not see a whole lot. So here, the way to interpret this, if it's blue, it's a positive correlation. If it's red, it's a negative correlation. The bigger and darker blue or red, the stronger the correlation is. What does correlation mean? If one increases, the other increases. For example, phosphorus increases yield. We did not really see that. We saw very weak correlation for all these different soil sample attributes and yield. That was kind of discouraging. We were like, well, a lot of work getting all these soil samples and putting it all correlated to the yields, but we still learned something. Some things very interesting, actually. We also had the different yield components of soybeans correlated to yield. What we learned was that seed number was much more correlated to yield than seed weight. And here you have the graph for that. And I'll talk more about this later on, and I'll explain why we now think seed weight is not as correlated to yield as seed number is. It's not that we cannot increase seed weight, but I feel like there's one nutrient that we're missing during grain fill that is limiting our potential to increase seed weights. Another thing we've learned is that there was a very strong correlation between soybean planting date and yield. And I'm pretty sure everyone here in this room have heard about the impact of soybean planting date on yield. The later you plant, the lower your yield will be. Interestingly, we could correlate as well seed weight and seed number, the two yield components, to planting date. And what we've learned is that with later planting, what is happening is we're lowering the seed number. And why would that be impacting yield? Well, seed number is a yield component. So the lower your seed number, the lower your yield. And the reason we're lowering seeds per acre when we plant later is likely due to two reasons. Less node number and also less pods per node. But these are some images coming from the University of Illinois looking at the planting date trial, 4 planting dates and the count of nodes. These plants are still growing, so we'll have a little bit more nodes, but what we usually see is the later you plant, the less nodes you have. With less nodes, you end up with less seed number, and with that, we have lower yields. That is true with this planting day trial at the University of Illinois. We also do this trial every year at our research farm in Pleasant Plains, and here you have the average of about 10 years of research at our research station in Pleasant Plains. So, knowing that soybean planting date had such a big influence on soybean yield, what we thought was, well, let's maybe separate this data by planting date and see if then we can find some good correlation or not. Since planting date is the #1 correlation we found, we decided to further investigate in different planting date groups. And that's what we did. We utilized the distribution. We broke it into 4 quartiles, I'm sorry, is a statistical term there, where you get the 25% first here planting dates, which would be planting dates in April, and we compared to planting dates in June, meaning super early planting or super late planting. That's the data we had in our data set. And then we wanted to compare, is there now a correlation between the soil test attributes and soybean yield, depending on the planting date. So let's first take a look at the early planting date and the different correlations with the soil test attributes. Again, this is the Pearson correlation. Positive correlation is positive means one increase, the other increase. Negative correlation means one increase, the other decreases. We did not see very strong correlations, some statistical significance, but the correlation was very weak. However, when we looked at the later planting date, we found that there is actually a very strong correlation between the soil test attributes and soybean yield. And that made us think, why would planting date be influencing the relationship between soil test and soybean yield? Well, we came up with some theories. The first is the rate of growth of the plant. When you plant early in April, you're planting under cooler conditions. The average temperature in Illinois in April is about 52 degrees Fahrenheit. In June is 74. The warmer it is, the faster that crop will grow. The faster it will grow, the faster it requires nutrients from your soil. Meaning, the soil might not be able to keep up with the plant demand because the requirement is so high when you plant late. So you gotta increase the availability of nutrition under those scenarios. That's the first thing. The second is the duration of the cycle. When we plant earlier, we increase the duration of the cycle. When we plant later, we're closer to the solstice and we decrease the cycle. With that, what we'll see is a difference in the rate of uptake of nutrients as well. Here you have soybeans planted early, representing a 175-day cycle. Later planting, maybe 120, 130-day cycle. This is the uptake of phosphorus in pounds of P2O5 per acre per day throughout that growing season. You see that the shorter the cycle, the more nutrition you'll have to take up in a shorter period of time, meaning you'll have to have more concentration of those nutrients to increase the rate of nutrient uptake. There's a very strong correlation between concentration of nutrition in the rhizosphere close to that root system and the rate of nutrition that the plant can take up. So if we have a longer cycle, the peak demand is much lower. Meaning our soil might not have to be as concentrated in those nutrients because we spread out the uptake of those nutrients throughout the season. If we have a shorter cycle, our peak uptake is much higher, meaning we'll require higher concentrations to keep up with the plant demand to achieve the same yield potential. And there's no such thing as producing more soybeans with less nutrition. So if we don't provide here the amount required for that given yield, our yields will drop. That is true for phosphorus, potassium, nitrogen, all the different nutrients. So that's why we started thinking maybe it has to do with the rate of uptake of those nutrients from the soils. So some key takeaways from the first part from this project that we did at the University of Illinois. Soil test attributes are not well correlated with yield when soybean is planted early. Likely because early planting will result in slower growth and slower rate of nutrient uptake. The soil can keep up with plant demand. Soil test attributes have moderate to high correlation with yield when soybean is planted late. Likely because late plant will grow faster, will require nutrient faster, and you'll need to increase your nutrient concentrations in the soil. So one recommendation we came out from this study is that potentially, this is not for sure because we did not put any trials to confirm this, but potentially if you plant your earlier fields where soil tests are lower and save your highest testing fields for later planting, you'll probably get the highest total yield from your farm. Because later planting will require more nutrition. Maybe if you plant those in where you have more fertility in your soil, you might end up with a higher yield at the end. So this was the first part of my presentation, and I said that I want to talk a little bit about nitrogen and why I think nitrogen is so important for soybean yield. I'm going to go back to this graph where I show the correlation between the different soil test attributes and soybean yield. You can see that for both early and late planting, and even when we did the overall analysis with all the different soil tests for all the planting dates, organic matter was resulting in the strongest correlation for both early and late planted soybeans. Why is that? Well, what is soil organic matter? I think everyone here knows, but one definition of soil organic matter is that soil organic matter is the fraction of the soil that consists of plant or animal tissues in various stages of decomposition. Well, soil organic matter will have several functions in your soil. It can be a source of nitrogen, phosphorus, sulfur, also some micronutrients that can get trapped into the organic matter. After it mineralizes, it can release some micronutrients. But these are the main nutrients that are going to be bound to organic matter in your soil. Over 90% of nitrogen, over 90% of sulfur, phosphorus on average more than 50% is in the organic form. In Illinois, Dr. Margana told me he found some soil samples that had over 90% of the total phosphorus in the organic form. So organic matter is a huge reservoir of nutrition in our soils. It's also a source of cation exchange capacity. It also lowers bulk density and better aggregate stability, increases water holding capacity, and improves microbial activity and also microbial diversity. But the point that I want to make here is that the nitrogen in organic matter is what I think is the most important part of organic matter here for growing beans in Illinois. Illinois has the highest soybean yield from the country. It's actually 65 bushels this last year, which was the same as Iowa. But if you look at northern and southern Illinois, all the soils in southern Illinois are rich. There are soils that have high base saturation, are soils that are not necessarily poor, but the main difference is the concentration of organic matter. And if you look at yields in Illinois, northern central Illinois have usually much higher soybean yields than southern Illinois. I think a lot of it has to do with nitrogen, and that's what I want to bring to your attention here. Remember this graph that I showed you where I have the two different yield components correlated to yield? Seed weight is not very well correlated to yield in this case, but I don't think that's because seed weight cannot increase yield. It's because we're missing a lot of opportunity. When is seed weight determined throughout the soybean growing season? So here you have the two different yield components and when they're determined throughout the soybean growing season. Seed number will be determined all the way to R4, and seed weight will be determined when seed is being filled from R5 on. Who is managing soybean pest R3? Very little people. So maybe we're losing a little bit of potential because we're not actively managing for seed weight. And one of the things that I think is limiting a lot of the seed weight increase is this: soybean senescing. Soybean senescing means we're losing photosynthetic capacity. By losing photosynthetic capacity, we're losing the capacity to fill heavier seeds. Why are we senescing? Well, it's an limitation during grain fill that is making the plant remobilize nitrogen from the leaves into the grain. And I'm going to explain how that is happening. So soybean, as I said, has a huge nitrogen requirement. Almost 4 times as much as corn does on a per bushel basis. And a lot of that nitrogen goes into the grain. From 70 to 80% goes into the grain. Why does nitrogen goes into the grain? To form amino acids that will form protein. Soybean is a protein producing machine. 35 to 40%, depends on where you are, it's protein, and that requires a lot of nitrogen. Do you see what's happening here? When we get to R5, this is showing where nitrogen is inside the plant throughout the growing season. Nitrogen is going to the leaves, stems, petioles, flowers, and then grain. We get to R5, what happens is we start remobilizing from the leaves into the grain. And a lot of research has already shown that we might be limited on nitrogen. This is research done in Nebraska. It's actually kind of like a meta-analysis they did. This is kind of old, 2008, but they were already seeing that we're likely limited on nitrogen. This is yield of soybean without N fertilizer, and this is yield of soybean with N fertilizer. Anything above the 1-to-1 line here means it was higher yield with nitrogen fertilizer than without. So it's showing me that we're likely limited here. Here's another study also from Nebraska, but also using some data from Argentina. Yield with 0 N, yield with full N management. Anything above the 1-to-1 line here means we have higher yields with N fertilizer than without. A lot of the data points are above that line. One interesting thing this study did was it separated the 2 different yield components, seed number and seed weight, correlated with and without nitrogen fertilizer. Where do you see the biggest difference? Is it in seed number or is it in seed weight? It's in seed weight, meaning nitrogen is probably limited at the back end of the season after R5. It's not limiting the production of seed number, but it is limiting how heavy those seeds will be. And where is our nitrogen coming from on a soybean plant? Well, we know that half is coming from the soil, half of it is coming from the air. It will vary. If our soil has less nitrogen, usually comes more from the air. A lot of areas in Brazil, for example, 70, 80, 90% comes from the air. It varies, but on average in Illinois, half. And how are these 2 sources providing nitrogen to the soybean plant? Well, you can look at this nitrogen assimilation graph here that looks at the nitrogen uptake in kilograms of nitrogen per hectare day from planting all the way to physiological maturity coming from the soil and the air. The soil is the black line, the air is the red line. What we see is that at the beginning of the season, because we don't have nodules, we're relying 100% on the soil. After nodulation kicks on, we are relying mostly on the air. But what happens at R5? We see that our nitrogen supply from the air suddenly drops. Why is that happening? Well, we're losing the number of active nodules after R5. This is right at R5. This is another research that was looking at the number of active nodules at R5. We're losing the active nodules. Why does that happen? Well, nitrogen fixation, it's a process that requires a lot of energy. So Haber-Bosch process utilizes a lot of pressure, a lot of temperature to break that triple bond. It's a very hard bond to break down. It's also very hard for the microbes to break it, so it requires a lot of energy. This energy is being provided by the plant through photosynthesis. What happens at R5? At R5, we're going to start filling the seeds, filling the pods. Those pods now become the strongest sink for photostimulants inside the plant. Now the energy that was going down to the roots and feeding those microbes is not anymore. It's actually filling the seed. So because of the lack of energy going down there, we're not keeping those nodules alive. And when we don't keep those nodules alive, our soil is the main source of nitrogen. A lot of times, the soil does not provide enough nitrogen during grain fill, and that's when we start seeing remobilization from the leaves. This year was a pretty dry year at the research farm during grain fill. We were almost 50, 60 days without a measurable rain during grain fill. I thought our yields were going to be low, but because we were not leaching a lot of nitrogen, actually we got record yields at the research farm. 60 days without rain during grain fill. 104 bushels, like super high yields for us on average, and I think a lot of that has to do with less nitrogen leaching during grain fill. With that we have more nitrogen availability, with that we have higher seed weights. Last slide I want to show here that really I think summarizes everything that I said. So this research was done in Wisconsin back in 2017. They were looking at the nitrogen uptake rate for 3 different yield levels of soybean. Low yield levels, 3,600 kilograms, that will be about 60 bushels, let's put it that way. 60, 70, 80 bushels. Low, average, and high. Here is nitrogen uptake in kilograms per hectare a day. What do you see until we get to R5? There's not a whole lot of difference between the 3 different yield levels. Meaning nitrogen availability or nitrogen uptake did not change much for the 3 different yield levels up to R5. It's after R5 that we start seeing big differences in nitrogen uptake, and what they saw is that high yielding soybeans will take much more nitrogen during grain fill than low yielding soybean, and there won't be much of a difference during vegetative growth. So I really think that we are limited on nitrogen during grain fill. Do I think we should be applying nitrogen? Definitely not. If you apply nitrogen, you're probably going to kill your buried rhizobium. If there's free nitrogen in the soil, the plant tends to not establish the inoculation process. So it's something that we don't really know exactly what we should do, but we think that by making the machinery more effective, the nitrogen fixation process more effective, we may be able to delay senescence of those nodules, and with that, increase seed weights at the end. So I'm not bringing any recipe here on what to do with the nitrogen, but it's just something I really wanted to bring up that is something we've been talking a lot about, is about nitrogen during grain fill and how that can limit soybean yields. We've been talking to some record yield growers, and we see that what they do is actually they apply a lot of nitrogen, so that's how they get there. They're not relying only on what the air is providing. Well, with that, I would like to thank you all, and I would be glad to answer any questions.